Hello students, let's go to the next topic about syllabus, that is nothing but absorption, reflection and transmission of heat radiations. So if you remember, the name of the chapter is what? Kinetic theory of gases and radiation. Up till now, whatever the theory we have learned, the pressure exerted by gas molecule and that all things, that is the part of the kinetic theory of gases. Now this is the part where we have to learn the absorption, reflection and transmission of heat radiation. So this part comes under radiation. Kinetic theory of gases we have seen. Now we have to see the remaining part of the radiation. Now what is the radiation? Might be, if you remember, in 11th standard we have learned about this. Radiation means what? One of the mode of transfer of heat. Heat can be transferred from one point to other point by three methods. The first, if you remember, we have learned this: conduction. Heat can be transferred either by conduction or convection, and third one is nothing but a radiations. So if you remember, all these parameters already we have learned. Conduction means what? Heat can be transferred in terms of actual migration of particle or without migration of particle. With a vibration of particle, heat get transferred from one place to other place. That is a conduction, vibration of particle. Convection, heat get transferred from one place to other place with actual migration of particle. There is a convection. And radiation is the third method where heat get transferred from one place to other place in terms of emission of electromagnetic waves, and that is the radiation. So this conduction and convections are the method of heat transfer where they require a material medium for their transfer of heat. If there is no medium, heat cannot be transferred by conduction and convection. But this radiation is a method in which heat can be transferred from one place to other place, whether there is a medium or there is no medium, still heat get transferred. So this radiation is a method in which heat always get transferred from one place to other place. Heat energy transfer with medium or without medium also. So this is radiation, and this is the fastest method of transfer of heat among all these three: radiation in terms of electromagnetic wave. So this part already we have just learned in 11th standard. So just I have revised it, and one of the best example for this is what? The light ray coming from the sun on the earth's surface. In between earth and sun, there is some part where there is nothing, that we can say there is vacuum. Still that light ray travel from the sun and they come to the earth's surface, because that comes in terms of electromagnetic waves, and that is nothing but by the method of radiations. So that radiations we have to consider here. So radiation is a method of transfer of heat from one place to other place in terms of emission of electromagnetic wave. So that is the thing. But remaining things, conduction and convections, already we have seen in 11th standard in detail. So this is a short revision of this. Now let's go to the interaction of this thermal radiation with the matter. When this thermal radiation incident on the matter, how they will interact with it, that we have to see. So here, suppose Q amount of heat is incident on the body. Suppose in general Q amount of heat incident on this body. Suppose this amount of heat is incident on this body. Suppose this is any body on which Q amount of heat is incident on this body. Out of the Q amount of heat incident, some amount, that is suppose QA amount of heat, QA amount of heat is absorbed. A for absorption. QA amount of heat is absorbed by the body. Okay. QT amount of heat is transmitted by the body, and QR amount of heat is reflected by the body. So see, Q amount of total radiant energy incident on a body, out of that some of them QA get absorbed, some of them QT get transmitted, and some of them QR get reflected. Then from this we can write simple equation: the total radiant energy incident equal to what? Amount of radiant energy absorbed, QA, plus amount of radiant energy transmitted plus amount of radiant energy reflected. So we get this equation. Divide both sides of this equation by amount of radiant energy incident, total amount Q. Divide both sides of equation by Q. What we get? 1 equal to QA divided by Q plus QT divided by Q plus QR divided by Q. Now in this case, this part QA divided by Q is called as A, coefficient of absorption. This is said to be coefficient of transmission, represented by small t. This is said to be coefficient of reflection, represented by small r, and both are all addition equal to 1. Means 100% radiation incident on a body, some of them get absorbed, some of them get transmitted, some of them get reflected. Meaning of this. So what is A means? So this A, from this equation you can write A equal to QA divided by Q, and this is said to be coefficient of absorption. So that is coefficient of absorption, and this coefficient of absorption can be explained as it is a ratio of amount of heat radiation absorbed to the amount of heat radiation incident on a body is always constant. That constant is said to be coefficient of absorption. Similarly, what is coefficient of transmission? Amount of heat radiation transmitted divided by amount of heat radiation incident on that body, that is give the coefficient of transmission. Similarly, represented by T here. Here coefficient of reflection, ratio of amount of heat radiation reflected to the total amount of heat radiation incident on the body is always constant, and that constant is said to be R, and that is said to be coefficient of reflection. So in this fashion we have learned here coefficient of absorption, reflection and transmission. Apart from this, just most important point to remember, from this equation we have written here A plus T plus R is always 1. Suppose some material is there, for that material T and R are 0, then what is A equal to 1? Because T equal to 0, R equal to 0. What does it mean? That body is a perfectly absorptive body. Whatever be the radiation incident, whole get absorbed because coefficient of absorption is 1. Whole thing get absorbed. But what about transmission? Nothing get transmitted, nothing get reflected, everything get absorbed. Then that body is said to be perfectly black body because it will absorb all the radiation incident on it. So whatever I am going to taught you here, if you got 100% understanding of this, that means your absorption coefficient is 1. Okay, just for example, absorption coefficient 1. Suppose I have taught you 100% of topic here. Out of that, you are getting only 20%. 20% get absorbed. Okay, then 40% get transmitted. Okay, and 40% get reflected in your case. Okay, that means what? Out of 100% I am going to taught you, you are getting 20% only. 40% you can't recognize. It get transmitted or it get again much 40% get reflected. So there is loss of 80%. 40% in transmission, 40% in reflection. Same thing is here. So if 100% I am just taughting you here and you are getting everything, that means your absorption coefficient is good. Okay, your understanding is good. So that is the meaning of this. So this is the first case when A equal to 1, T equal to 0, R equal to 0, A equal to 1, body is said to perfectly absorptive body. Apart from this, suppose A equal to 0, T equal to 1 and R equal to 0. Here T equal to 1, body is such that it can't absorb anything, it can't reflect anything, but it will transmit only. Just incident, whole energy get transmitted, nothing get absorbed, nothing get reflected. Then that is said to be perfect transmitter. Initially perfect absorber, perfect transmitter. Next would be what? A equal to 0, T equal to 0, R equal to 1. R equal to 1 means it is perfect reflector. It can't absorb, it can't transmit, it directly reflect. So these are the nothing but what 3 cases, and such type of 3 students are available in the class. 3 students are available in the sense what? Some student, they get 100%, whatever be taught by a teacher, they get 100%. So they are absorptive. Second type, transmitted. They are physically seated in the class. Students seated in the class physically only, but they didn't get anything, they didn't understand anything. So that is absorption is 0. Reflection is 0. They are showing to teacher that they are going to concentrate in the lecture, but still there is a transmission. Just hear from this ear and leave from this ear. So that is transmission is there only. Okay. And third type is the student. They are physically seated in the class. They just concentrate toward the blackboard. That showed they are concentrating toward the blackboard, but actually they can't absorb anything. They can't transmit anything. Nothing can go in their brain. They just incident here and reflect here. Incident and reflect. No, it can't go inside. If it go inside, at least it transmitted or it get absorbed, but it reflected from their ear own, directly reflected. So that type of student also. So what do you think? Which type of student is best? This would be, if you understand everything, that is good. Transmission is not good. Reflection is not good. So it is better if you get everything here I have taught you. Or suppose you get some percentage, 80% you are getting, 20 transmitted, 20 reflected, it's good. So that are the example. Just this is, I have correlated with the different type of students. So I hope that you get a basic concept of absorption, reflection and transmission. Whatever with the heat radiation incident on any body, some of them get transmitted, some of them get reflected and some of them get absorb. So here after this, just they have just mentioned one body, that is perfect black body. Before going into perfect black body, about to this there is one paragraph. In that paragraph they have mentioned one important parameter. Suppose some body is there whose transmission or absorption is 1. So transmission is 0, reflection is 0. So this body is said to be perfectly absorptive body. But this will be occur at certain wavelength lambda 1, suppose. At this wavelength A equal to 1, T equal to 0 and R equal to 0 at lambda 1. So there is a probability there is another wavelength lambda 2 for which A may be 0, T may be 1, R may be 0. Means what? The same body will behave as an absorber at wavelength lambda 1, another wavelength lambda 2, it work as a transmitter. So this thing can be occur with the body. Same body at one time it can be behave as a absorber at one wavelength, and another wavelength same body may behave as a reflector or transmitter. Same thing they have mentioned. Now let's go to next topic, the perfectly black body. As we know, they have the word used here, perfect black body. So let's start with the perfect black body. Now here we know the word perfect. Perfect means 100%. Nobody is perfect, we know. Still, perfect black body is a perfect black body is a body which is said to be perfect, ideal, we can say, ideal black body. And we know the ideal things are very much differ from the original things. So perfect black body is a body which will absorb all the radiation incident on its surface. Everything get absorbed, nothing get reflected, nothing get transmitted, everything get absorbed, and that body is said to be perfect black body. In practice or ideally, no perfect black body exists, but we can consider lamp black, as they have mentioned in your book. Lamp black, this lamp black can be assumed as it can be absorb 97% of heat radiation incident on it. That's why it can be assumed as a nearly perfect black body. Lamp black means what? When we glue the lamp, at the top, black color powder get created, just deposited on the surface of the top, and that black color powder is said to be lamp black. And that lamp black has a property that it will absorb 97% of heat radiation incident on it. So we can consider this lamp black as a one of the example of perfectly black. 100% is not possible. We can take a nearly perfectly black body. So perfect black bodies are the body which absorb all heat radiation incident on them. At the same time, when they absorb, they emit also. When we hit such type of perfectly black body, this black body has a property that whatever we think they have absorbed, everything they will emit. So good absorber are good emitters also. Same thing they have mentioned below that. Before going to that, they have taken one example. Suppose we have one chamber. Suppose we have some enclosure. In this enclosure, we have kept two bodies. Suppose this is one body, this is another body. So this is B1, body 1, this is B2. Both have same surface area. Just if you see the diagram, you can't see the same surface area. Let us assume both of them have same surface area A. And here, the first body is such that B1 is such that outer surface is polished, well polished outer surface. And B2 is such that it is perfectly black body. Perfectly black body means what? It will absorb everything. So these two bodies, when we kept in this chamber, it is seen that whatever with the radiation incident on black body B2, it will absorb everything. And whatever with the radiation incident on B1, it get reflected because this surface is reflective surface, polished surface we have created. So it will reflect. So it will reflect, and that reflection get absorbed by this body, black body, because it is black color, and it is black color means what? It will absorb all radiations. So everything emitted by this, they get absorbed here. So that is nothing but a polished surface and perfectly black body. They have mentioned this thing in your book. So this is the basic part of the perfectly black body. Now here there is one scientist whose name is Ferry. Ferry tried to explain how the perfectly black body works. For that he has created his own perfectly black body. Just I have drawn it here. So let's go to that topic now. Ferry's black body. So what exactly Ferry? Ferry is the name of the scientist who tried to create a perfect black body by his own. So what he has done, he has taken the two spherical shape, two spheres he has taken. The first one, just this dark one I have shown, this is inner sphere. and this is outer sphere. The another one is outer sphere with a very small aperture, very small hole at one end. So this is the aperture here. Both the spheres are concentric sphere such that they have very small aperture, very small hole is here. And exactly opposite to this aperture, there is this conical projection. So this is a conical projection is here. Why the conical projection? That will see later. Conical projection is here. So whenever heat radiation is enter in the body through this aperture, they will incident on this conical projection and they get reflected. Multiple reflection, the whole heat radiation get absorbed inside the body. That is the basic aim of the Ferry. So what he has done, he has taken two concentric sphere such that they have a small hole here that is said to be aperture. Exactly opposite to the aperture there is a conical projection to reflect the heat radiation enters in the sphere. Now here inner surface of the sphere, inner surface of the inner sphere, inner surface of the inner sphere is coated with the lamp black. So just I have just used here somewhere I have mentioned. So see, surface coated with the lamp black, inner surface, just I have shown inner side arrow, inner surface is coated with the lamp black. What about the outer surface? Outer surface is silver polished surface, so nothing can be absorbed. Outer surface it get reflected, inner surface it get absorbed. And the space between two sphere, this sphere and the outer sphere, this space is evacuated. Evacuated means what? We have removed all the air particles, matters, molecule, everything is removed. We have created vacuum here. That is said to be evacuated space, means vacuum get created. Okay. Apart from this, when the heat radiation enters to the aperture, incident on a conical projection, and as this is coated with a lamp black which can absorb 97% of heat radiation. Suppose this heat radiation comes with 100% heat radiation comes inside. Out of that, here with the forced reflection 97% get absorbed. How much is remaining? 3%. Now 3% comes here, and here this 3 out of 3%, again 97% of 3 get absorbed here, then remaining get reflected. So within a few reflection, 2 to 3 reflections internally, whole heat radiation get absorbed. So he says that this is the body which behave as a perfectly black body, and that is nothing but a Ferry's black body setup. Most of the time in examination they have just asked the question, draw the Ferry's black body with nomenclature. So you should draw it properly and give the name like this. Okay, so this is nothing but a Ferry's black body. Apart from this, they have mentioned in the same topic, there is one scientist whose name is Wien. Wiens has used the black body similar to Ferry. Instead of spear, what he has done, he has used a cylindrical part. So what he has done, just I will draw here, he has used such type of cylinder. So such type of cylindrical part he has used, and instead of small aperture, he has created one hole here, line, straight line hole he has created. Suppose just might be as in the money bank, there is a box, such type of box is here, and here at the top here one small opening is here like this. From this we can drop a money or we can drop a notes. So that type vertical thing. So he has created such type of lining here. So through this line the light get a heat radiation incident inside, and cylinder has more surface area, so there is more area to absorb this heat radiation. So this is nothing but a setup done by the Wiens. Apart from this, again at below the diagram in your book they have mentioned cavity radiators. Might be all of you have heard about cavity radiators. So it is cavity radiator. So this cavity radiator consists of one small cavity, and inside that cavity black color portions are deposited, and that will behave as a perfect black body again. So that again they try to explain here. So this is cavity radiator, again similar to that. It is convenient to work with the ideal black body. So this is nothing but a assume as an ideal black body. So within some reflection whole thing get absorbed. Let's go to next topic, Einstein heat radiation, emission of heat radiation. So emission of heat radiation means what? The body which can absorb the heat radiation, that body can emit also the heat radiations. So that is we have already learned the